In April 2026, excavators began tearing into the North Campus of Giga, Texas, as Terafab officially broke ground. This is a $25 billion project focused on 2-nanometer chip technology, bringing together Tesla, SpaceX, xAI, and Intel, four major players sitting at the same table. But this raises an important question. Why did Musk bring Intel into the picture, and what does Intel gain from this partnership? On April 22, 2026, Musk confirmed that Terafab would use Intel's 14A process. Almost instantly, Intel's stock jumped by 3.6%. That led to even more speculation. Who is actually building Terafab? Is it Tesla or is it Intel? To understand why Terafab matters so much, we need to start with a simple question. What does Tesla need to survive over the next decade? The answer isn't batteries, motors, or even factories. It's chips. Every Tesla on the road today relies on chips to power its full self-driving system. Every Optimus robot needs advanced chips to understand its environment and make split-second decisions. Even every Starlink satellite requires specialized chips that can withstand cosmic radiation, something you can't just order from a typical supplier. Here's the number that changed everything for Musk. All chip fabs on Earth combined can currently meet only about 2% of the chips Tesla and SpaceX will need in the near future. Not 20%, not even 10%, just 2%. So what do you do when the market can't supply what you need? Musk first tried securing supply in advance, signing a massive $16.5 billion deal with Samsung in July 2025. But even that wasn't enough to solve the long-term problem. Because when you depend entirely on someone else for the most critical part of your business, you don't truly control your future. That's why on March 21, 2026, Musk stood on stage at the historic Seaholm Power Plant in Austin and made a blunt statement. Either we build Terafab or we don't have chips, and we need chips. So we're building Terafab. No alternative, no backup plan. So what exactly is Terafab? It's a joint semiconductor manufacturing project between Tesla, SpaceX, xAI, and Intel, with an initial budget of $25 billion. The goal is ambitious, to produce 1 terawatt of AI computing capacity per year. For context, the entire United States currently produces only about 0.5 terawatts. Musk wants Terafab alone to double that. What makes Terafab unique is its vision to bring the entire chip production process under one roof. Design, fabrication, lithography, memory production, packaging, and testing, all based in Austin, Texas. No single project in semiconductor history has attempted to control the entire chain in one location like this. Of course, making bold claims is one thing. Executing them is another. Construction began in April 2026 on a 5.2 million square foot area at the North Campus of Giga, Texas. This is Phase 1, the prototype phase. The goal here isn't mass production, it's learning. Initial output will be just 3,000 wafers per month, which is tiny compared to the millions processed by companies like TSMC. But this is just the foundation. The first chip in development is AI-5, Tesla's 5th-generation chip designed for both autonomous driving and the Optimus robot. Small-scale production is expected by late 2026, with mass production planned for 2027. So why start small? Because Tesla has never built chips before. A 2-nanometer fabrication plant isn't something you can master quickly or scale overnight. It requires decades of expertise, atomic-level precision, and countless failed attempts before producing a single perfect wafer, and that's exactly where Intel comes in. On April 7, 2026, Intel announced on X that it was proud to join the Terafab project alongside Tesla, SpaceX, and xAI, highlighting its strengths in chip design, fabrication, and packaging to help achieve the 1 terawatt goal. That announcement immediately sparked debate across the tech world. Some saw Intel's involvement as a sign that Terafab is credible and achievable. Others argued that Tesla can't build a fab on its own, and that Intel is the one doing the real work behind the scenes. The reality lies somewhere in between, and that's what makes this story so interesting. Intel brings its advanced manufacturing expertise, including its cutting-edge 18A process, currently the most advanced chip production technology available in the United States. Intel contributes its advanced EMIB packaging technology, which allows different types of chips to be combined into a single, high-performance module. Even more importantly, it brings decades of experience, teams of highly skilled fabrication engineers that Tesla simply couldn't develop on its own in just a few years. So, what do Tesla and SpaceX bring to the table? Real demand, massive capital, and a brand powerful enough to reshape an entire industry. This isn't Tesla struggling because it needs Intel. It's Tesla making a strategic decision, partnering with the right company instead of spending a decade trying to figure everything out from scratch. We've seen this playbook before. Tesla once partnered with Panasonic to produce lithium-ion batteries at Gigafactory, Nevada. At the time, no one claimed Tesla had failed because it didn't build its own batteries from day one. Instead, Tesla learned, gained experience, and eventually developed its own 4680 battery cells. Terafab is following a similar path, just on a far bigger scale. On April 22, 2026, Elon Musk confirmed that Terafab will use Intel's upcoming 14A process for chip manufacturing. Earlier discussions focused on 18A, but 14A represents Intel's next-generation technology, expected to launch around 2027. This means Terafab is betting on a process that doesn't even exist commercially yet. It's a bold move. But if it works, Tesla could become the first company in the world to run chips on Intel's most advanced node. For Intel, the stakes are just as high, arguably even higher. CEO Lip-Bu Tan had previously made it clear that without a major customer for the 14A process, Intel might consider exiting the chip manufacturing business altogether. Now, Musk has effectively stepped in as that customer. Following the announcement, Intel's stock jumped 3.6% in after-hours trading. One statement from Musk, and suddenly Intel is back in the game. That's the level of influence Terafab already has within the global semiconductor industry. Looking ahead, the current work at Giga Texas is only the beginning. Musk has indicated that a full-scale Terafab facility will require thousands of acres at a completely new location that hasn't been revealed yet. The planned scale is staggering, around 100 million square feet, roughly equivalent to 2,000 football fields. For comparison, Musk noted that Samsung's Texas fab is about 8 million square feet, meaning Terafab could be around 12 times larger. The ultimate goal remains clear: 1 terawatt of computing capacity per year, double the total output of the entire United States today. But before getting carried away with the ambition, it's important to take a step back and look at the real challenges. This isn't hype, it's analysis. The first challenge is the massive gap between the current budget and the projected cost. While $25 billion sounds enormous, analysts at Bernstein Research estimate that reaching 1 terawatt of computing capacity could ultimately cost anywhere from $5 trillion to $13 trillion. That's up to 200 times the current budget. However, there's an important nuance here. The $25 billion is only for the prototype phase, not the full build-out. No company constructs the world's largest chip fab overnight. TSMC, for example, built its dominance over decades with continuous investment totaling hundreds of billions. So the real question isn't whether $25 billion is enough. It's whether Musk has the long-term commitment and resources to see this through. The second challenge is something money alone can't fix: access to EUV machines. These machines, which use extreme ultraviolet light to manufacture 2-nanometer chips, are essential, and there's only one company in the world that makes them: ASML in the Netherlands. The problem? Their production capacity is already fully booked through 2027. That means no matter how much funding or manpower Terafab has, it still has to wait its turn. This isn't a problem that can be solved with speed or innovation. It's a hard limit of the global supply chain. The third challenge comes from an unexpected direction: water. Gigafactory Texas already uses about 556 million gallons of water per year, a number that has increased significantly in a short time, making it one of the largest water consumers in Austin. A typical chip fabrication plant would require an additional 365 to 700 million gallons annually. And Austin sits in a region prone to drought. Local environmental groups have already raised concerns, formally requesting strict accountability measures if Tesla fails to meet its environmental commitments. This issue doesn't have an easy solution, and it could become one of the most serious bottlenecks for the entire Terafab project. Before Terafab, Tesla relied on companies like Samsung and TSMC for its chips, paying market prices, depending on their production timelines, and having little control over how those chips were actually made. With Terafab, that changes completely. For the first time, Tesla can optimize its chips all the way down to the silicon level, not just at the software layer. Every chip can be built specifically for Tesla's needs instead of being designed to serve hundreds of different customers with generic requirements. A good way to understand this shift is to look at Apple's move in 2020, when it transitioned from Intel processors to its own M1 chip. The result? MacBooks that delivered significantly higher performance while using far less power, and Apple never looked back. Musk is betting that Terafab can do something similar for Tesla and SpaceX, but on a much larger industry-wide scale. This isn't just a story about building a chip factory. It's not even about competing with TSMC. It's about companies taking control of their own future in a world where semiconductors have become more critical than oil. Of course, the risks are real. $25 billion might not be enough. Intel's 14A process could face delays. Water shortages in Austin could become a serious constraint. But the project has already begun. And history shows that the ideas people doubt the most are often the ones that end up changing everything. So what do you think? Is Terafab a once-in-a-generation vision or the biggest gamble the chip industry has ever seen? Share your thoughts in the comments. I read them all, and I genuinely respond. This channel exists for one reason: to break down complex technology stories into clear, honest, and accessible insights. No barriers, no fluff. If this helped you understand something better, drop a like so I know I'm on the right track. And if you think I missed something, say it directly in the comments. Your perspective is what makes this space better every day. If you know someone who's into tech, share this video with them. That's the best way to grow this community. Subscribe to Street Horse Power so you don't miss the next deep dive. See you in the next video.